Really appreciate being here at DjangoCon Europe, even though it is like 4:45 in the morning. I got all prettied up for everybody so we could talk about Django channels. I think actually someone needs to mute.
Agora posso para a minha posição. Ok.
I think Joe needs you need to mute. I can't mute you.
Aqui está.
Can I?
Ainda está fixe. Está fixe, está fixe.
Hey, David, I need someone to mute over there.
As coisas ficam estranhas porque ele tem ali a lareira atrás e faz bocado mais de
Hold on 1 second. We'll get started here as soon as I can mute. They're very loud.
Né? Gajo é todo gay. Não, fica muito difícil, mas não fica conversar.
Yeah, there we go. All right, awesome. Now we're rolling. So welcome to DjangoCon Europe. My name's Hendryx-Parker. I am co-founder and CTO of 6 Feet Up, but I assume you all know that because you've probably seen the little pre-roll ads. But I'm excited to be here and talk about hacking Django channels for fun and profit. This is something that is actually really, really relevant for what we're all doing here right now today because we're using it in the Loudswarm platform. So I'll talk a little bit about backstory and where we're going and how we did all the things we're doing. There's a later talk today where I'll talk more about the cloud infrastructure that makes up Loudswarm. But this talk specifically is going to be about the under the covers of how we're using channels to do some cool WebSocket stuff. So let's get rolling here. First, a little bit of backstory to kind of set the context. Back when Django started life in 2005, it was a synchronous web application server because really nothing else kind of existed in the space. It was definitely cutting edge for what it was at the time. But async is becoming more and more a part of Django with each of the new 3.x releases. But to understand that that difference between the synchronous web and the asynchronous web is really important for understanding the modern web applications that we're building today. So if we talk a little bit more about what the Django request response loop looks like, you can see that we're this is the standard Django like request and response. So when requests come in, they go through all the various like middleware that you configure in your settings.py, and then they hit your view function, and then they actually go back through the middleware on the other side out. So this is a request, and then there's a response. So it's all synchronous, happens just as it comes in, just as it goes out. This is how Django is going to be processing those. There's actually a really good video here that describes that in like much greater detail. And this is all done synchronously since we're living in WSGI land or WSGI land. So WSGI, when you hear that term, is going to be the synchronous part of Django. But let's actually talk about the asynchronous part of Django because that's why you all are here, is to talk about asynchronous and not necessarily synchronous. So let's make this actually work bidirectionally. So normally when you want to establish a connection to some kind of a, for example, if you're establishing a connection to a database, that's like a long running connection. We would want the same thing for our web application to be able to talk to Django. We'd want to be able to establish some kind of a connection that we can make requests down and get responses from. But the opposite can happen. The web application itself can take and send requests from the application to our browser and provide some kind of interactivity. So that is where we get the difference between ASGI and WSGI, WSGI. So the ASGI is an asynchronous gateway interface, and that's what allows us to do this bi-directional. So in Django, which is kind of cool, you can just change out WSGI pi for ASGI pi. There's a really nice guide there from Aaron who talks about Django 3.0 and the performance and moving into asynchronous. And also yesterday, Amanda did a really great talk with an intro to channels, and she talked specifically about this, actually coded through the process of building a sample chat app where she used ASGI, and I'll talk about the router and setting up the routings. But you know, this whole ASGI versus WSGI can really be its own talk. But ASGI is a superset of WSGI and can even call WSGI callables, and I'll show that in a code example later. But prior to Django 3, Django channels provided the ASGI asynchronous support to allow for those long-running connections like WebSockets or MQTT and more. And this allows us to use a fully asynchronous event loop inside of the Django application server, which was historically synchronous, but as of 3 has grown these nice asynchronous features. And just as a note, each version of Django 3 since 3.0 has added new asynchronous features. So like, for example, in 3.1, well, in 3 we got the routing layer. In 3.1 we got views. 3.2 has added a few more bits in there. We're supposed to add in the asynchronous ORM, but that's not quite ready yet. So that'll be coming very soon to a Django near you. So that's the kind of back inside of Django. How does that back inside of Django talk to the browser, which is basically the consumer of your application? This is where we come into using WebSocket. So if we want to see WebSockets in action, I'm going to give a quick little demo here showing that in action. So if I click over, you may recognize this screen since you're watching it right now. Luckily, I don't have the audio on, so you shouldn't hear me. But the web application for Loudswarm uses WebSockets in one very specific area right now that you can see that's visible to the end users. If you look at this track Slack box down here, these messages are coming real time, pushed from Slack over into the web application using WebSockets, and we can see those sockets if you open up the web inspector. And if you scroll down here, you'll see I've got the WebSocket showing in the network tab of my web inspector, and here you can see the various like messages. So a lot of these were people clapping. You can see here there was the preview message coming up, hacking Django channels for fun and profit. I didn't have to reload my page for those messages to come into the page. The WebSockets pushed them to me, and so actually, if someone was brave enough, they could actually yep, there we go. So you can see new messages coming in real time against this socket, and they would just show up here as people were chatting into the Slack channel. So that's actually what the WebSockets are doing for us, is giving us that bidirectional access. In our case, we're using it from Django to the web browser as opposed to from the web browser to the Django. But you can actually use that to enable all kinds of really rich UIs and applications where the web can now feel like an application and not so much a request and response, full back and forth stateless type of a transition. Because HTTP, as we all know, is a stateless protocol. It means that every request is like a whole brand new world. It's like the web had amnesia, and every request I make is going to be a brand new request out to the world. But WebSockets allows us to establish some manner of state back to the server. So channels is the Django component, as Amanda showed yesterday in her awesome talk, that adds in the inbound WebSockets. So our browser can connect to Django channels, subscribe to a consumer, and now messages can be sent back and forth over that channel for WebSockets technically. Really what it does is, it wraps asynchronous views. So we now have the ability to do that, keeping our full async event loop and everything going. So that's actually, kind of now where things come in, is channels. So Django channels offers us 3 main components that help us build these rich web applications. The main one that you'll typically interact with, which was shown yesterday in the tutorial, was the consumers. This is what we typically think about when we talk about channels and WebSockets. You would write a consumer that would listen for various kinds of messages coming either in or going out. You can send messages over the channel layers. The consumers is just kind of the easy way we interact back and forth between our application and the browser and the web application on the back end. The other 2 pieces that we don't typically think about when we're interacting as a developer with channels, if we're not dealing with kind of deep back of the stack type things, is going to be channel layers and the background workers. So when we use channel layers, that's when you send a message to the consumer to send something to your web browser or the socket. And then the last one is actually what's going to be really interesting for us, is the background workers. I don't remember when this feature was exactly added into channels. This allows for very lightweight background tasks, kind of like a Celery. So if you're familiar with Celery, you can create tasks that run asynchronously in some worker someplace. Here we can create a worker that's a little lighter weight, but doesn't have all the robust features of Celery, and actually run them straight in Django without having to add in the whole Celery package. It creates a background worker command that you'll run to run your background tasks. For example, when doing something on these background tasks, I'll talk about this a little bit later, but you can do things like generate thumbnails asynchronously as folks maybe upload photos into your imaging site. But let's look at the consumer real quick. This is an example of a channels consumer. You can see that it has a connect and a disconnect. So there's basically a simple API where you implement these methods on your class for your consumer. And so in our case, we accept the connect, we give a connected equal true. If you're actually playing along at home and watching the WebSockets in the Loudswarm application, you would see in your JavaScript console like these connected true messages, or on the network tab, these connected true messages coming in. Disconnect provides you a way to clean up or do some kind of closing activities once the WebSocket closes. What's more interesting probably is going to be the receive JSON. So if we set up a receive listener, this is going to process things coming from the browser, and you can then make decisions on how to handle that. We'll talk about sending messages to a consumer later, so you can actually send messages to the channel layer so that those can get back to the browser. That's just basic JSON WebSocket consumer. Channels makes it really, really easy to implement these and add this kind of rich interactivity to your applications. How do you get this all hooked up into Django itself? Well, we want to be able to hook into the Django routing, since actually there's a really good talk, I think it's Andrew Godwin from 2019 DjangoCon US, where he talked about adding in asynchronous features to Django. When you ask Django for a URL, it's going to respond with some kind of routing. So you all are familiar with the routing.py and how you can specify URL patterns. When you start going into the asynchronous world, you're going to need to handle multiple types of protocols. In our case, we're going to have the standard HTTP protocol. So as of channels 3, you need to make sure you specify that HTTP protocol type router so that it can hand that off to the standard Django URL routing mechanisms. But we also want to be able to handle WebSockets. So when our browser makes a WebSocket connection back to our application, it can route that off. In this case, you see we're wrapping a middleware around our URL router for our specific application's URL patterns. And there's a last one in there, which you're probably not familiar with, is you can actually have a channel named router. In this case, we're going to make, it's basically channel views where we can now establish WebSockets, persistent WebSocket connections from Django to another application. So this is where things are starting to diverge from the normal Django channels talk. Is normally we're talking about a chat application or some kind of a simple WebSocket connected to the web browser. This is not a web browser talking to Django. This is Django talking to another WebSocket service and establishing a persistent connection outgoing from Django to something like, for example, Discord. So we're going to talk about how that works. So in this case, we're using a Discord to be able to listen to a Discord guild specific channel and be able to grab messages in real time as they're happening in Discord. So there's a big difference between how we do Slack and Discord in Loudswarm. The Slack integrations are not using a WebSocket connection. They're actually webhooks that are coming from Slack. They hit an endpoint on Django, which is just a standard Django view. And then that actually triggers a channel send to get that message all the way to your browser. The Discord integration mechanism is different in the case that Discord integrations are done via WebSockets. So we actually get to use fully asynchronous all the way through with WebSockets from Discord to your browser. So we're just kind of picking those up and putting them in the right place and making sure that everything works great here. So let's talk about the background workers. This is where we can try and establish those channel connections to Discord, for example, or normally, we think of what I talked about earlier, the channels consumer where a web browser is talking to Django. Background workers are new to channels and I guess a little less used and maybe not getting the airtime they need. So I'm hoping to expose some of you all to how we can use background workers to do some interesting work. If you look in the docs, there's an interesting example there around generating thumbnails with a background worker. So you can actually, as part of your code, maybe you've got a signal that would send a layer message to a specific channel view, not a Django view or any other kind of views inside of the synchronous Django bits. We would actually kick off a worker to do some kind of work in the background. But that's normally like Django initiating a call to a channel layer and doing some work. What if we really wanted the reverse? What if we wanted, a web browser establishes a bidirectional channel to our apps, one thing, but what if we wanted to establish that channel connection to some other long-running service, like I mentioned with our Discord? This is where we pull in and actually, use that background worker in channels. And let's talk about what we can do with that a little bit here. Is that we want to sit and listen for messages on a channel layer and then do some work. That's what channels background workers normally do. What's nice about the channels implementation as opposed to using Celery, as I mentioned a little earlier, is that it is much lighter weight. You're not bringing a whole bunch of extra machinery along the way. The channel workers are very, very lightweight, very, very fast, very easy to use. But there is a caveat, like a little note here, kind of the beware. They are an at most once operation. I'll let that sink in a moment because you have to be careful and you have to design your application with that understanding in mind. We want to make sure that we're not losing messages if they are important. If your application depends on guaranteed delivery and maybe one-time processing, there are other queue technologies that are more well suited to handling this. That's why we have Celery, and Celery is still a use case that we use in Loudswarm because we have different kinds of applications that need different kinds of needs. And at most once operation works when something can be lossy. So for example, like I mentioned with the thumbnail generation, you can have it do that in the background to try and offload from the main Django application so it doesn't have to generate those synchronously. So the user's experience can appear or be perceived as a lot faster because we can do those things in the background. We're not worried about generating a thumbnail on an upload synchronously at the same time, which is what we would have done kind of pre-Django 3, pre-channels, is you would have had to kind of wait for that process to finish running, or you would have had to use Celery to process those later. But Celery may be a little heavyweight for this, and also we may be okay with it not happening right away. It could be that on some request for that specific image, we could generate the thumbnail on that at that point in time if it didn't exist. So we can kind of work with the system and allow us to use this lightweight mechanism. So that's the generating thumbnails example. But let's talk about the real world use case we're seeing here, which is our Django Discord chatbot. So, but built inside of Django. There's lots of great example chatbots for Discord written in Python out there. And why didn't we just use one of those? Well, for us, having Discord tightly integrated with the chat mechanism is important because we want to be able to use things like the Django ORM to save those messages off into the database once they come in. So, Discord requires me to talk asynchronous to it and use a WebSocket to send and receive. I mentioned how we do Slack using the webhooks, but why is it important that it's inside of Django? In our case, I'll tell you, is that the batteries are included. I want to use all of the awesome stuff that's included inside of Django, and the big one here is I want to use the ORM. I want to be able to make sure that it's just super easy for me as an application developer to save data into the database without going outside of Django itself, writing my own SQL methods or whatever it is to talk to Django from an external process. I can actually integrate this into my development workflow and actually have it all be part of my Django application. Now, the issue is we want to do something that channels can do, but doesn't do out of the box. If you refer back to my the routing example where we had the HTTP, the WebSocket, and the channel router. When you make a channel layer request to the channel protocol, it's just like a view. You're going to have to call it if you want to kick something off. So you could write a consumer and attach it to that route for a channel protocol, but something would have to kick it off. So the whole bit that doesn't work, and the whole reason I'm probably talking today about this is because this is one thing that channels doesn't do out of the box, but could do. You can actually, I was trying to, but basically the problem was on Django's start, how do I get it to kick off a persistent connection to Discord? That's the total problem statement there. And the answer is you're going to have to hack the channel's background worker a bit. So this is what we're going to talk about here. Is we can do this by making our own version of the runworker. So we basically we just copied over and overrode the handle method on the background worker. And this is the the only code we changed about that background worker to really get the kind of, this is the key bit of how this all works. And what is working here, and I'll kind of point it out. If we look, we've added in, for lack of a better term, a list of lackeys, which are going to be tasks that we want to set up to work in the background. So we get those. For example, we wanted to create an outgoing connection to Discord API. We set up all these keys, all these tasks in our background worker, and then we kick them all off, and then we wait for results. If they, for example, if they error out or if they exit at some point. And there's two kinds of things we can do here, and I'll talk about this more as we go on. Kicking off a long running process. This also allows us to set some kind of on start tasks for Django, which could be an interesting use case that maybe when a Django worker starts up, or when a Django process work starts up in your cluster, there may be some startup tasks you wanted to do, but it's never, again, very easy to set that up and have it work out of the box. But Django channels runworker actually allows for that very, very easily. So by adding this little bit of code into our default worker method for Django channels, we've actually been able to now kick off, or start an asynchronous process right at Django start time. So again, this helps us turn that standard Django channels concept a bit inside out, where instead of waiting for a request to a channel layer, we can initialize that right off the top. So if we talk about like some examples, I'll dive into this a little deeper. So when we run that worker, we're going to start up our chat client. So we create our own Discord chat client and then kick it off so that it starts listing for those messages. So this is just a standard. Actually, if you use discord.py, I want to give a big shout out to the Discord Pi project. What an amazing set of documentation and library and APIs. It makes it super easy for you to start building. Sorry, I try to remove the word easy from my vocabulary because developers shouldn't say anything's just super easy. But I'll say it's very convenient as a developer to use Discord Pi to build Discord applications. And using it inside Django is no different. We just have to think in an asynchronous fashion, kind of different from what we've been doing from previous versions of Django. So we build our chat client. In this case, we just, super subclass from the Discord client. We listen for messages. We set up data, and then we just wait for that data to come in. So as new messages roll off, like on messages inside those channels, we set this up, and then we just pass that off into another method that calls into the ORM and saves our data into the database for us to send. Then, well, it does two things: saves it in the database, and then it also sends a WebSocket connection to your browser, so you get the Discord messages in your browser. So that's how that's all hooked up. So it's pretty straightforward. That's like literally all the code there is for making the chat client part of the Discord. Now what happens on the sender, if we want to send messages to Discord, so we kind of we have bidirectional here. If there's messages coming in, we would actually want to send those messages. For example, you'll see the conference messenger inside of Slack right now sending the updates saying coming up in 4 minutes, here's the next talk, next speaker. We want to be able to support that behavior as well. So we still have the Discord sender, which is a consumer, just like a standard channel is this consumer, except instead of talking to our browser, it is talking to the Discord services in the cloud. So we just set up a new message and then do the channel.send. So we get a nice and easy using channels. We're using channels both directions here, sending and receiving of messages. This sends over that same client. So you can see we're using our Discord client from our Discord worker to send those messages. And this is how we send those messages. So once we have a task to send a message out, so for example, we use Celery on a scheduled task to look for all sessions that are coming up in the next 5 minutes. It crafts a message and just calls Discord send, and it's away it goes. But you can use this for any long running task, which is pretty awesome. If you've got specific needs and you want to be able to run a long running asynchronous task in the background, the channels workers are really, really well suited to this type of application. And I highly recommend it because it's really easy to work with and it feels very much like you're working in Django. So if you really love the Django framework and you love the feel of it, I recommend checking deeper into the background workers of Django channels because it's pretty awesome. Now, what I want to see next. I would love to get this added into the Django's code base with some examples and documentation and tests. So that's kind of our next step. We're working on that right now. It's not a big code change, but in open source, you got to be a good open source community member. And I want to make sure we do it correctly and have tests and everything so that it can all go. I think giving more examples of long-running processes and single-shot coroutines would be good. Sometimes it's hard to conceive of ideas or why this is useful, and I think seeing examples is important. So working on the documentation for us to put this out there is also coming up next. And then we want to add in the option for two kind of classifications of these coroutines. Ones that start right away, so like a long-running Discord connection to Discord servers, for example, and ones that can run and then, or ones that can run if they stop. So you kind of got three classifications. Though there's things that can run right away and stop. There are things that are long-running and will continue to run until you stop the server, and then things that can run after as a cleanup mechanism to your long-running process. So, for example, if we were running in the Discord long-running server and the Django server was getting ready to shut down, or there was the socket closed, we would actually want to be able to schedule certain kinds of tasks to actually run in response to sockets closing or the Django server getting ready to shut down. So that's coming up. Right now, we've only focused on our specific need, which was to create long-running tasks that can run and talk to Discord. I'll leave you all with one final kind of tip and trick, and then I'll kind of check out. I've not looked in the questions here yet in the Slack channel, but I'll check those out in a moment. That something that's not in the docs, but probably should be, maybe I need to make a pull request here, is when you're dealing with channels and WebSockets, you have to think about scale. One thing that's probably not obvious as a new developer to channels is that every person who logs into your WebSocket is establishing that persistent connection back to your web server or to wherever you're running your application. Each of those connections requires memory. So there's some simple calculations you can do. You can look at how much memory each new connection takes, but you have to also take into consideration that channel layers, the layer below the consumers, also has a default capacity where it will start queuing up. Well, it actually doesn't queue up. It will basically has a threshold, and after that, it starts dropping messages. Remember how I said there's a at most once delivery? We ran into this with this specifically. Is your channel layer capacity defaults to 100. If you start pushing more than 100 messages at a time, or if that level starts growing above 100, they will drop silently, and you'll be scratching your head as to why. For our application, we changed it up to 1,000 with no adverse effects on memory. We will have to watch your memory, because as you start tuning these numbers up, obviously there'll be more resources used. So make sure you are aware that channel capacity is really like it's a I can't wait to call it what the concept is, but basically as soon as you reach 100, it's going to start dropping them silently, and you won't get those messages. I mean, you can still keep sending more messages into it, and it's going to keep processing them as it can get them, but it's only going to process the 100 that are sitting there right now. So you'll want to up that number. It's something you can set in your settings file to get that channel layer capacity up to over 100. And with that, I want to say thank you all. I want to thank the DjangoCon Europe organizers. I really enjoyed this conference, and I'm super excited I was able to be a part of it as a speaker this year. Let's see if there are any questions over in Slack.